Hello, welcome to Get Business Insights Faster with Machine Learning on AWS. Now, first, I want to get some housekeeping out of the way. When you joined today's webinar, you selected to join either by phone or computer audio. I want to let you know that you can change that for any reason if you'd like to during the webinar. Also, from the control panel, you have the opportunity to submit questions for the presenters today. You just type your question into that questions pane and we'll make sure that it gets moderated correctly and answered. Now, if we don't get to your question live, we will follow up via email. The deck is going to be available through SlideShare, along with the recording of this webinar. Give us 2 or 3 days after this to get it ready for public consumption. Now, my name is Chris Burns, excuse me. I'm an AI and ML solutions architect here at AWS, and I'm going to be your host and moderator for today's webinar. So for the speakers today, in addition to myself, obviously, we have Vinod Iyengar. He's Director of Product and Alliances at H2O.ai. Also today, speaking from G5, we have Martin Stein, the Chief Product Officer, and Jeff Hazel, Senior Software Engineer. So for the agenda, we're going to try to pack quite a bit into 1 hour. I want to give you an overview of machine learning solutions offered by AWS and some of the partners in our APN network, some of the great work that they're doing. So the feature partner today, of course, is H2O.ai, and they're going to present their customer G5, an excellent, very, very interesting use case. Finally, we're going to save time for Q&A and discussion. So make sure you get those questions ready. This is a great time to get live answers directly from the source. Now, what we want you to take away from the webinar today is some concepts, some ideology around implementing ML successfully with minimal data science experience. That's actually a really important topic here because data science is hard. We all know that. Data scientists are expensive. We know that as well. And AI ML is becoming ubiquitous. It's becoming to the point where if you don't have it, it's going to be difficult to compete. So how do you get that implemented? We want to show you how to build tailored production-ready ML models. I love the production-ready phrase there because running a Jupyter notebook and getting some accuracy from a model is one thing. Putting that out into the wild, where it's going to be hammered by by public consumption or whatever production process you have, is a whole different thing. And then finally, excuse me, we want to show you how to solve real-world challenges from detecting fraud to diagnosing diseases. I kind of call that applied ML. Learning from a tutorial is great. It's good to get you a lot of great skills, but how do you take that knowledge and look at a business process and then actually put AI, ML into practice for yourself? So with that, we can talk about AWS, machine learning on AWS, excuse me. So now here at Amazon, excuse me, I do apologize. Living in Texas, you think I would be free from flu-like symptoms. So at Amazon, we've been making investments in ML back as far as 20 years. And I want to talk about Amazon holistically for a moment. I know many times we separate Amazon.com from AWS, but I'm going to put us back together into one conversation here. But it's important to remember that many of the capabilities customers experience with Amazon or on Amazon were driven by machine learning. If you think about the origins of AWS itself, it's found in the practice of building up a technology internally to Amazon and then offering that to our customers. Bit of a lag here, I apologize. So I'm going to quickly draw some attention to the robots in our fulfillment centers. These paths are optimized. This is 100% machine learning based. This is not something that would be possible for a human to do. And if you ever had an opportunity to visit one of these fulfillment centers, I really, really recommend it. Because it's quite an orchestration of math. It's a thing of beauty if you see these robots moving around, just missing each other, pausing for humans. It's a great experience, and that's ML based. That's ML driven. It wouldn't be possible with that ML. And in addition to the fulfillment centers, our entire supply chain, our forecasting, and our capacity planning are all informed by machine learning algorithms. Now, I guess the takeaway there is you don't grow to the size of Amazon without implementing ML. I apologize, I've clicked through again. Now, before we had to optimize the routes of robots and fulfillment centers, we were focused on search and discovery. So this is a screen that should be familiar to most people. It's a simple recommendation engine. Now, recommendation engines, the concept is quite simple. We recommend a product based on your past purchases or past items viewed. But these are very powerful recommendation engines that work at a massive scale. I mean, very, very massive scale. And to harness that type of data, again, you're going to have to leverage, you're going to have to move beyond statistical models into neural models, recommendation engines. Just another example of what we've been doing here at AWS for many, many years. Now, because machine learning is a recombinant technology, meaning it can be combined with nearly any existing technology to create something new, we found many new opportunities to infuse machine learning into existing products. And some examples here are, for instance, on the Kindle. If you think about reading a book on a Kindle, here's an example of where we've allowed you to click on a character and then go out and sort of, I mean, I don't want to use the word hyperlink here, but you could click onto a character and then gain more insight or more information about that particular character. That's done with topic modeling, essentially. It's entity recognition. It's recognizing characters within the greater text from nouns and verbs. Excuse me, a character would be a noun, but hopefully you know what I meant there. It's recognizing the characters separate from the other text. Another example is Fire TV. Any Fire TV that's equipped with the X-ray feature uses facial recognition technology to provide the viewer with some pretty useful metadata. Now, I want to be clear here. This particular picture that you're seeing on the slide was not created in real time, obviously, because the people are facing away. But it was persisted somewhere. But the original collection of faces was done with an AI agent. So this is a technology that was still leveraged for a very useful purpose. And it's created a great experience for end users, so you don't have to wait until the end of the movie to figure out who's in the credits. And now, finally, all this experience has given rise to completely new products and ideas that were never before possible. And I'll just give a couple examples of those, which should come as no surprise. The first one would be the line of Echo products. And it was probably the first generation of these products that helped technologies such as automatic speech recognition, continuous speech recognition, and a couple other NLP features really go mainstream, really go into the home. Oops, I do apologize. That's the slide I should be on. Now, if you've been paying attention to the Echo line of products, you're going to see an evolution of sorts. The first ones were speakers. The newer models have LCD screens and cameras, and I'm not going to speculate on what additional ML technology will come to the devices, but it shouldn't be hard to visualize a pretty wide range of features and capabilities within your home made possible with the computer vision in addition to NLP. And now, speaking of computer vision, my last example here is the Amazon Go store. These are now, I think, in 4 locations. So we have Seattle, Chicago, New York, and maybe the Bay Area. I do apologize, I'm not sure. If you have a chance to go into one of these stores, I highly recommend it, even if it's just to experience it. And now what this is, it's a retail store where you walk in, you put an app on your phone, and you can pick the items that you'd like, and then walk back out. This is based on computer vision. I want to make sure I draw that distinction. This is not based on RFID tags or similar sensor or telemetry technology. This is based on computer vision. And now, I don't want to sound like it's name dropping, but we are excited about the range of customers that are running machine learning workloads on AWS today. Which brings me to the ML stack, which is one of my favorite slides. It's a great overview of the capabilities on AWS from top to bottom for machine learning. And I'm going to spend make sure I watch my time here. I've got precious little time left. The top layer, application services. These are APIs essentially that are ready to consume by developers. A very clean JSON RESTful interface. If you want to incorporate image recognition, text to speech, speech to text, language translation, chatbots, these are all built for you, ready to be consumed behind a simple API. Very, very attractive pricing plans, free tiers for almost all of them so that you can try them out before you buy. And moving down the stack a little bit, we have what we call platform services. Amazon SageMaker is a major player for us. I'm going to talk about that. It gets its own slide in just one moment. But we have the AWS Deep Lens now. That's going to incorporate machine learning in the form of computer vision at the edge. You can use SageMaker to push your trained models to a deep lens. It's essentially a camera that runs at the edge, so you get inference at the edge, and then you can take action right there at the edge without going back to the cloud. Amazon Machine Learning is one of our very first products. It's still out there. It's a great product for doing regression. If you want to experiment with some ML or some data sets or use it as a learning tool, Amazon Machine Learning is still out there. Also, we have Spark and Amazon EMR. Spark runs great on our Elastic MapReduce products and is a great option for those that have those legacy Hadoop clusters that they want to update. And then finally, Mechanical Turk. Mechanical Turk has been here almost since day one. It probably should have been back there with the other slides. And sometimes I think people forget about that. But if you talk about human in the loop training, you talk about annotating images or labeling images. When it's 1,000, that's one thing. When it's 1 million, when it's 5 million, you need to look at options like Mechanical Turk, where you can set up these jobs to have those images either labeled or some other type of process that requires a human in the loop. And then finally, our frameworks and infrastructure. I don't like to use the phrase IaaS is pretty legacy term, but this is infrastructure ready for you, building blocks ready for you to use as you see fit. If you need a fleet of P3s to train some pretty complex neural networks, if you have to train on terabytes or even petabytes of data, then you're probably going to come down here and you're going to put this fleet together from the services that we have. We support any framework on AWS, so you don't have to use one particular framework. We welcome them all. They run all equally as well. Now, if you have even more specific workloads, I want to draw your attention there to the FPGA. That's the Field Programmable Gate Arrays. What that means is you're going to use the F1 series of instances to customize the hardware to optimize a single algorithm. So, excuse me, if you have a business model where you've settled on one particular algorithm that really is the heart of your business, and you want to optimize that even beyond one of these Intel CPUs, then you can look at the FPGA. And then we did it again. So we have SageMaker. Real quick, I know I'm running out of time here. I'm going to speak quickly. SageMaker is a platform for bringing machine learning to the masses. I don't want to say that masses as a dismissive term, but one of the goals, one of the missions here at AWS is to put machine learning in the hands of every developer, every architect, every builder. Now that's difficult because what we found is that data scientists aren't great cloud architects, and cloud architects aren't great data scientists. This is a platform that allows those teams to work together. It also allows anybody within that machine learning lifecycle to assume any other role and get a good handle on what's happening with their machine learning training, what's happening with the hosting services. It allows you to do this without ever worrying about provisioning your own resources. It's a completely managed service. Again, if you have an opportunity to try out anything on Amazon related to machine learning, I definitely recommend SageMaker to take a look at that. And in my final slide, before I hand off, I wanted to address the machine learning competency. If in the crowd today we have some other AWS partners that are interested in the competency, this is a great program. This is something I'm personally involved in. I vet all use cases that come from our ML partners for this competency program. And what this is we get the little badge icon there because it really is a badge. It's like a gold star. We've certified this partner. Has a robust plan for tackling machine learning based problems. They have great solutions, and we've vetted their use cases, and they know what they're talking about, and they're really good at what they do. So with that, speaking of really good at what they do, it's my pleasure now to introduce Vinod Iyengar from H2O. Vinod, I do apologize, Vinod. It's Vinod Iyengar from H2O, and he's going to take it from here. Now, again, get your questions in the questions box, and we'll get those answered as soon as possible.
Thank you, Chris. Hello, all. Thank you for the opportunity to present in front of all the amazing people that have gathered here today. Vinod Iyengar, I head product and alliances here at H2O. I've been with the company for a little bit more than 3.5 years. The mouse click is, there you go. Sorry for the lag. So today the topic for us is automatic machine learning with driverless AI. That's our new product, and we'll talk in a little bit more detail about that product. That's kind of the goal today. For folks who don't know about H2O, quick overview. We were founded in 2012, so we've been in business a little more than 6 years now. We are the creator of the open source platform, also known as H2O, and nearly 14,000 organizations globally use us in various forms and shapes. This includes enterprises, governments, universities all across the world, and also nearly half of the Fortune 500 are using our open source platform. We are a venture-backed company, and some of our lead investors include folks like Wells Fargo, NVIDIA, Nexus, and Paxion. We also were named as a leader in the Gartner Gartner Magic Quadrant for machine learning and data science platforms. And we'll talk about that in a little bit more detail. We are about 120 folks right now, which includes a mix of some of the world's best AI experts, including Kaggle Grandmasters. For folks who are not aware of Kaggle, Kaggle is an online tournament for data scientists who compete for fame and a little bit of money by delivering the best data science results. Essentially, the way it works is companies offer a challenge and some prize money, and data scientists get an opportunity to fine-tune their models and compete on a global scale to build the best models. When they win a number of competitions, they can claim a grandmaster title or status, very similar to a chess grandmaster. And as it turns out, there are only about 100 grandmasters in the whole world right now. And H2O has about 7 of the top 10 of the top 100 grandmasters in the world. We also have an amazing visualization, distributed computing, and AI team that solves a whole lot of problems. And finally, H2O is a global enterprise. We are headquartered in Mountain View, California, but we also have offices in London, Prague in the Czech Republic, and in India. Quickly, I want to talk about the Gartner Magic Quadrant. This came out earlier this year. This is the MQ for data science and machine learning platforms. A couple of key points to remember is H2O, of course, was named as a leader, but we're also named as a leader with the most completeness of vision. What they mean by that is that our technology bets, including GPU integration, ecosystem development, and automation, were way ahead of others in the quadrant. But the interesting thing to note is that they named this as a quasi-industry standard. What they mean by that is that most of the other vendors in the MQ actually use the H2O open source platform under the hood. So our algorithms and frameworks are being consumed by many other companies in the ecosystem, in the space, and that's why they named this as a quasi-industry standard. One thing that I'm especially proud about is the fact that H2O received the highest overall score from its customers. We take customer success and satisfaction very seriously and work very hard to ensure that our sales relationship, account management, support, satisfaction, everything is top notch. And that was reflected in the Gartner MQ as well. And finally, Driverless AI, the new product in H2O, were named as InfoWorld 2018 Technology of the Year, which was a nice sort of pat in the back as well. So what can you do with H2O, right? So just I want to talk to some of the use cases that we are seeing in the industry, right? So across, and H2O is a platform that can be used in financial services, healthcare, telco, marketing, retail, or any other vertical for that matter. It is a horizontal platform that has the best algorithms, blessed data science, all baked into it. But what are customers doing with it? So if you could look at financial services, you have things like KYC, know your customer. People are trying to solve anti-money laundering with that. There's a lot of other top banking customers are using H2O and Driverless AI to solve things like transactional fraud detection, collusion fraud, real-time tracking, etc. If you go across to healthcare, we're seeing really interesting use cases like early cancer detection, doing product recommendation, personalized drug matching, for example. On the insurance side, we're doing use cases around medical claim fraud detection. We're doing things around payment benefits and much, much more. Coming to telcos, a ton of use cases around predictive maintenance, doing better customer satisfaction using avoidable truck rolls. We do things around customer churn prediction, and also helping improve the in-network experience for some of these telco customers. We'll obviously talk a lot more about marketing and retail. That's the use case that's in attention with the friends at G5, but we just want to highlight the fact that we also do use cases around funnel predictions, personalized ads, clickstream prediction. We do things around next best offers, smart profiling, etc. Jump to the next slide. Sorry for the lag there. So why driverless AI? So H2O, the platform is extremely widely popular and used by a whole lot of data scientists. The reason we built driverless AI was that we found there were sort of 3 big impediments to enterprise AI adoption. Now, everyone, there's no surprise that AI is one of the hottest technologies in the field, and most CIOs are already making it the mission statement for making AI in all their entire workflows. In fact, all of digital transformation is now being replaced into AI transformation. But the big 3 challenges we found are talent, time, and trust. What do I mean by that? So when it comes to talent, there is a deep shortage of folks who have good analytical skills or good data science skills. There's just not enough data science expertise in the whole world. And this is a problem that is widely acknowledged by most industry experts and analysts. And as a proxy sort of data point, I like to point to Kaggle, where there's less than 100 grandmasters in the whole world. And if you even expand the pool to masters and experts, you're talking about a few thousand people for in terms of supply against the demand of 500,000 or so data scientists. The next problem is of time. There is a big problem in terms of the time it takes to get insights. So whether it be building good models, even if you're a data science team, or putting these models to production, as Chris pointed out, there is often different tools that need to be stitched together to get an end-to-end pipeline into production. And that's a big challenge because these frameworks or platforms or tools are often disparate, and you need a lot of time and sort of money to get this all done. The third big challenge we found is that even after you go through all the pain and build a good model, these models are often not trusted by business users, stakeholders, and regulators. And that's because of inherent lack of trust in AI. Obviously, there have been some very notable like errors or mistakes made by models which are caused some worry. But more importantly, some of these complex models, nonlinear models like deep learning or gradient boosted trees, often give you very little insight on how exactly predictions we've made. To the next slide. So how do we solve for that? So we solve for that each of these three problems with driverless AI. So that's kind of what we set out to do. So we solve talent by essentially automating the workflow of a data scientist. So we asked ourselves the question, what if we take some of the best Kaggle grandmasters, the best experts, and look at the workflow and try to automate that and essentially put it in a box? And that's what we set out to do with driverless AI, and we succeeded to a large extent. We have taken their best workflows, recipes, and automated that inside the software. So that solves for the talent problem. Then the second thing we did is we also use automation to reduce the time it takes to build insights. So the workflow for data scientists involves things like feature engineering, model optimization, tuning, feature selection, training, and then generating deployment code. And each of these steps can be time consuming and laborious. We have automated the entire workflow now so that all these things can be done with very little delay. The second thing we did is we use the best hardware and software combinations out there for optimizing our models and algorithms. What I mean by that is we use the latest GPU-enabled instances, as GPU and CPU-enabled instances from our friends at AWS or on-prem for that matter, but also using frameworks that can take advantage of the latest hardware. So we have rewritten algorithms from scratch to make them fully optimized and parallelized and take advantage of GPUs, for example. The third thing we did is we built an entire team and a framework around trust and interpretability. So we are one of the leaders in machine learning interpretability and explainability. With that, what I mean by that is generating human understandable explanations and reason codes. So building a good model is not enough, but you need to be able to explain exactly how every single prediction is being made. That's what we are doing with machine learning interpretability. We are also able to now generate automatic documentation for all the experiments and models built. So that gives you, the data scientist, a way to exactly document and audit every single step of the process. And finally, we are using automatic visualization to help understand the shape of the data and quickly uncover any errors or issues in the data even before they get started on machine learning. This is extremely important because the type of data, the quality of data you put in is directly correlated with the type of model you get. So with that, to recap, basically, driverless AI essentially is delivering AutoML for enterprise, automatic machine learning for the enterprise. It is a single platform for doing automatic AI and machine learning. It performs the entire workflow of an expert data scientist, fully going through the steps including feature engineering, model building, selection, tuning, and deployment. We also do visualization and interpretability to help deliver insights and explanations. And finally, every single we are generating automatic documentation to help explain the results and using good visualizations with a really nice and intuitive GUI to help fulfill the need. Driverless AI is also completely optimized for the enterprise, meaning that it comes with a whole bunch of security features that enterprises demand. It can scale to use massive data sets, and it's available in all different environments, including AWS. And we obviously have a very easy way to get started. It's a 21-day free trial for starting on driverless AI and building your experiments. I covered this a little earlier, but just to recap, driverless AI, just like H2O, is now basically being used across all different industries, in insurance, manufacturing, financial services, healthcare, retail, AdTech, and MarTech. All kinds of use cases, like from things like predicting better patient outcomes on healthcare and saving lives, to going from in retail and predicting who's your next best customer and how to improve your customer experience. Every industry, AI is having profound impact, and driverless AI is helping accelerate the time it takes to get those results. I want to finally leave you with a couple of these case studies and codes. These are all available on the website. If you go to h2o.ai, you'll find a ton of information about what customers are doing. Oops, jumped ahead. And then you can try out some of those codes. This is probably a good segue for me to hand it over to our friends at G5, Martin Stein and Jeff Hazel. They have a really amazing use case using H2O and driverless AI on AWS. It should be very enlightening for all of us. Over to you guys.
Great, thank you, Vinod. So let's talk about what we have been able to do. First of all, start with the introductions. My name is Martin Stein, and I am the Chief Analytics Officer here at G5. And with me, I have Jeff.
Hi, I'm Jeff Hazel, Senior Software Engineer at G5.
Great. So let's, first of all, I want to say thank you to Amazon and H2O for giving us an opportunity to speak about our very short and very successful pathway here at G5 into machine learning and using AWS and H2O Driverless AI. Our company was founded in 2005, and we're basically serving the real estate market. The company is headquartered in Bend, Oregon. We have about 270 employees here in Bend, Oregon, and we are a leader in real estate marketing optimization for property managers. We help over 500 clients in multifamily housing, self-storage, and senior living by finding the right leads and filling their property vacancies faster and, most importantly, more efficiently compared to more horizontal marketing automation solutions. Or very often our customers or our prospects that come to us have basically not much in place. And the question is, how are we doing this? In today's digital age, the customer journey is constantly shifting across digital advertising, web, social, and consumers use different devices. Our product, the G5 Intelligent Marketing Cloud, focuses on those touch points, especially on the owned media and paid media. And you can see this listed in there. So we deliver high quality sales leads by providing services such as website services, SEO optimization, listings and reputation management, and also paid advertising and social media ads. So besides delivering high quality leads, the insights generated are also very important, and they're being used to fine tune our marketing campaigns to help optimize budgets and to do better targeting. And therefore, it's key for us to understand and measure the quality of each lead and how it gets originated. And oops, one too many. And in practice, leads get originated through different channels. You can see this on this slide: search, digital advertising, social media, and listing management like Yelp or Google My Business. Now, if the last touch point is a form submission, lead scoring, in fact, is pretty simple. It basically means attaching a value to a form to qualify an interaction as a lead, or maybe it's something else. Maybe it's not a lead. Maybe somebody is just filling out a form because a heater is broken. But it gets very difficult when you have to work with calls and call data, specifically at a high volume. Now, why is that so difficult? Calls are not structured data. And usually, at least in our industry, our customers, actually our operators, listen to them manually and then type into a CRM system if it was a qualified lead, or if it was something else. Now, why do calls matter so much? The somewhat dirty secret in our market, at least, is that lead capturing based on form interactions captures only a small fraction of those leads. Based on our research, we see that 90% of interactions are actually call based. And one of the very important findings is 1 out of 7 calls on average, and there's different markets show different results, but on average across all of our verticals show a commercial intent. Now, if we know which call shows commercial intent, the quick follow-up matters, because consumers are not willing to wait another day. They would like to have instant gratification, and that's what it all comes down to. Now, that basically set the stage for us to understand or to have a need for classification of call intent. Now, if we can automatically classify the caller's intent and measure its propensity to lease an apartment or a room or a storage unit, we can basically decrease the response time and increase the conversion rate. So for operators, that would mean they can follow up much quicker, and with callers that specifically present a high lead score and a high propensity to lease. On the marketer side, it's very important to see which channel generated a highly qualified lead. And then if you combine that with channel spend, you understand channel performance much better. So we can rank and optimize the touch points by lead sources. Now, in order to achieve this outcome, it was very clear we need to use machine learning, specifically NLP as well, to score and rank calls. Now, that basically allowed us to introduce a product called Intelligent Lead Scoring or Lead Scoring. And what you can see is basically 2 of the very earlier versions that we put out. On the left side, you see the marketing channels being rated by the qualified leads they produce, and it goes even further into the campaigns behind CPC, keyword level information behind CPC, and that allows us to provide actually much better optimization data points and signals to really fine-tune our campaigns and to provide even higher levels of leads and qualified leads. On the right side, you can see what I was talking about a second ago, about how the operators can follow up quicker with more recency indicated by hot, and combined with the lead score, you understand which call is actually the most important call to follow up. Now, turning vision into reality is the key question, because very often we get asked, so how did you do this? How did we do this? And we basically started out earlier in 2018 by building a training set. And that's usually a task that you have to do first before you get into all those wonderful models you create. You start with building a training set. So how did we do that? So we began listening to more than 100,000 calls, to be exact, I think about 110K for our first training set. And we classified those calls into 5 categories. We ended up actually, using just 2 categories at the very end, but we still have all of the 5 categories. And those 2 categories that really matter is that a high qualified lead, and that's being indicated by somebody who wants to rent something. And so we averaged about, to hand score, 1,600 calls a day, and we ran this through a period of time to really get to those 110,000 calls. And then we picked our transcription partner in February, and currently we're evaluating different partners as well. Amazon Transcribe was not available at the time, or I think it was only available as a beta version. And so now we're at the point of looking at transcriptions again, because they matter a lot, and they also matter in the context of the speed and how long it takes to actually get your calls transcribed. So with that in mind, we built our data science stack in spring 2018 as well. We had quite some experience with H2O 3, the open source product, specifically the Spark-based version called Sparkling Water. But we also saw that the new product that H2O offered at that time, H2O Driverless AI, combined on a EC2 instance on AWS, is potentially exactly what we're looking for. So what we established, and Jeff will speak in a minute about this a little bit more in detail, is We set up a sparkling water cluster on EMR, and we set up Driverless AI on EC2 on AWS. And we had a team of, I would say, total 3 people, 1 product manager, that's myself, and 2 engineers who didn't work full-time on this whole project. Now, much of the work on the modeling side was done in R, and much of the production side, that's the really interesting part, actually in this context, has been done in Python. And we're going to talk in a little bit about how did we actually transition from one world into another world, and how easy it was for us to basically build a product and a model that we could take into a product without much overhead, and being actually very, very fast. So I think this is what we call a very lean project. And it took us about 3 months in total. We had a few empty cycles in there where we were distracted, you know how it is, by doing other things. But with that, I'm handing over to Jeff, and Jeff will get us a little bit more insights about how we got from data to prediction.
Hi. Yeah. So as Martin said, we have this great concept, and we needed to make it into a reality. We run a pretty lean shop. It's just, as Martin said, he and I and a bright guy by the name of Kirk, we were able to build this out in a relatively quick amount of time. As Martin said there as well, we carved out that training set of calls. We had about 100,000 rows of hand-scored calls. We transcribed them into text, and we compiled them into a large corpus that we then stored off in S3. From there, we spun up an AWS EMR cluster running our RStudio, H2O, and Spark. And we ingested the data, ran it through a feature building Lambda directly from EMR. And I want to pause there for a second just to say that there's kind of a subtle but important component to that. I'll come back to it in a minute. But using that AWS Lambda, it actually is very important piece to the process of productionizing this. And so we go from EMR, we go through the Lambda, we build our features, and we bring them back into EMR, and we've got transcripts of text. We've got features to go along with it. Next thing we do is go and build a word-to-vec model. In H2O, we do that, and the sole purpose of that is we transform our textual data into a vector that preserves the semantic data. That way we have our text as numerical values so that we can work with them in a machine learning context. As another aside there, the H2O word-to-vec model, POJO, that we generate there, we export that into Lambda as well. We incorporate it into the feature building Lambda, kind of a 2-way process. And like I said, I'll get back to that in just a moment. The next step for us is to aggregate together all those vectorized transcripts, all that metadata, and stage that back into S3. And that way we can spin up H2O Driverless AI in a separate context, and we can access that data just by passing it around within AWS on S3. We deployed H2O Driverless AI on a large EC2 instance, lots of GPU power, lots of memory. And what's great about that is we can spin it up on demand and build models when we need to, spin it down when we don't. We take the models that we generate in Driverless AI, we export them via their Mojo functionality, and we actually wrap that in another Lambda and plug that all together. So I'd like to just kind of step back briefly here and just enumerate what the engineering team needed to do in order to move from that sandbox that I just described, where we're moving data from S3 through an EMR cluster to Driverless AI and back out. We need to make sure we check a few boxes before we can say that this type of thing is ready for production. For me, the number one thing is, and I come from a DevOps background, and so reliability is always front of mind for me. Obviously, we need to make sure the system is running for our customers when they say they need it. Any lost time in this particular case, as we're trying to triage and make sure that leads that have commercial viability are coming to the fore. Time is very important in that context. Additionally, reproducibility is key. If this works correctly, it can seem a lot like magic, as is true of all ML and machine learning tasks. And so if something goes awry, though, the flip side of that magic is we need to be able to quickly, efficiently go back through and figure out what changed. And if the results aren't reproducible, that's very difficult to do. The next thing that we needed to make sure of is scalability. Call volume, as you might imagine, ebbs and flows throughout the day. We need systems that are able to scale, they scale the demand and scale down when they're not in use. That way, we're scoring calls when there are calls, and we're not wasting cycles when there are no calls to score. And lastly, we're concerned with iterability. Excuse me. Our data changes, use cases change, we have seasonality and lease availability and things like that. And as those things kind of ebb and flow, we need to be able to iterate on models, test them, make sure that we're not breaking previous models, and allow ourselves to iterate more and more quickly. And so we took all those current concerns into account, and I feel like we struck a nice balance with them. With H2O, both with H2O 3 and with EMR and driverless AI, we were able to build these reproducible results and iterate really quickly. We then, with the deployments to AWS Lambdas, we wrap those in step functions, and we can achieve a really reliable and scalable infrastructure. It's pretty cool to see. And so, with all those concerns in mind, and with that sandbox in mind, we got to put it all together, put it into a production stack, and it looks a little bit like this. This is, of course, a bit oversimplified. Our engineer Kirk would probably, throw a few more bubbles in here to really capture all the hard work that went into it. But from a top level, this is really what we're doing. We have a large infrastructure that exists already, as you might imagine, and we need to be able to plug into it. And this is what we came up with. So when a live phone call comes into the existing G5 infrastructure, we pass it on to this new system. We then transcribe it in the same way that we transcribe the training data. Consistency is obviously very key. And we pass those transcripts along with the metadata onto the AWS step functions and Lambdas. And here's where I can circle back to that Lambda that I mentioned 2 slides back. This one is the same one that we use in the training stack. And this is a really important thing that I think is really cool. Maybe that's just me as an engineer, but the consistency in that data curation is really key. And being able to invoke the Lambdas in AWS directly from EMR allows us to use the same code and the same H2O models to train our additional models that we are going to then turn around and use in production. And that's a really, really huge development for us. And so lastly, after that, after we've built all of our transcripts into features, we combine those features together with metadata, and we run them through the resultant, the scoring model that came out of H2O Driverless AI. We've actually wrapped that in a Lambda as well as part of a larger step function. And out of that comes a call score. The resulting score we then throw into an SQSQ, which is really great because that allows us to interface back into the existing G5 infrastructure without having to do much to change that. And that way we're presenting our scores to our users as quickly as you might imagine is possible with this. And so I just wanted to enumerate here some of the specific features in both H2O and AWS that we're using to really help us realize G5's kind of larger vision here. First, those H2O POJOs and MOJOs, they allow us to move really quickly. We're actually, one cool thing that I didn't mention before, we're loading those models from S3 dynamically at runtime. And so we've got some Python code that goes out, pulls those in, and we can iterate really quickly because we can move new models into place without having to make code changes. One other thing that Martin touched on is they allow us to transition from R into Python. It's pretty seamless, right? We can export these models after we've developed them mostly in R, and then in our production stack, we're a lot more comfortable and we have a lot more competency around Python in a production environment. And they also make version tracking easy. This is something we are leveraging right away. I think we can leverage even more in the future, but it's something you kind of don't notice until you need it, and then it can be too late. So it's nice to have kind of a low barrier of entry to versioning and accuracy tracking so that we can go back and see what changed when things break and when scores aren't exactly what we expected. And then I just wanted to also call out all the different technologies that we're using on AWS to make this possible. EC2 on-demand computing, excuse me. As I mentioned, that allows H2O Driverless to really achieve its full potential because we can scale up compute as we need it. We can scale up when we need to build big models. We can do that as we need and turn it off when we don't need it. EMR is really great because it allows us to get a cluster up and running for data exploration and early model building. It's really quick and easy, and we don't have to worry about all the package installs and things like that. And S3, I want to call it S3 because it does get overlooked sometimes, but I've worked in environments before where moving data around is a really difficult thing. And the way that S3 interfaces with all the different AWS products so seamlessly, you kind of forget about it. It's really a huge thing. We don't have to worry about moving data around. And lastly, but certainly not least, AWS step functions and lambdas. They've been a really great way for us to build this easy, iterable, scalable infrastructure with limited code. It plugs into our existing systems very easily, and we can play around with the different pieces, kind of like building blocks. We get the exact flow that we want. We can kind of move things around as needs change, and it allows us to move really, really quickly. It's pretty great to see. And so with that, I'll hand back to Martin here, and he can kind of talk about what business outcomes we were able to see with this.
Great, thanks, Jeff. So let's talk about the results for a second. And we talked about pretty much what it took. First of all, on the machine learning, data engineering, economics. I want to spend a second talking about that. So, 2 engineers plus a product manager. Product managers usually less often the very technical people, but in this case, product manager with a little bit of background with data allowed us basically to build a highly accurate model, multiple models, obviously, on a holo test set. Most importantly is how those models actually score in the real world. And so we basically put our models to the test, and we also achieved a really, really high real world scoring accuracy, 95% there. And I think this kind of matches also with people, potentially is even better than people, because if you look at how people score a call, there are potentially a lot of mistakes people make as well, right? And they're very inconsistent with how they score. And so what we have is actually a very consistent way, high quality, and it allows us now on the economic side to build models much, much faster. So we are down, specifically with the help of H2O Driverless AI when it comes to feature engineering. And I just want to point out the version 1.4 that has a 1.3 already, tremendous support for NLP now, and new algorithms like LightGBM, which are fantastic for us because now we can actually sit down and get even more value out of the product. And that allows us to literally cut it down from weeks of feature engineering and have data people sitting there to hours, maybe we spend a day. And that basically combined on the EC2 that Jeff talked about, where we have 4 GPUs running and driverless AI is taking full advantage of that. That's the real advantage here. And now, with regards to how we affect the business, that's of course fantastic because, as I said earlier in the presentation, that in this case, time is money, and responding to prospects in a matter of minutes, maybe seconds, and not days or hours, is really key if you want to rent out a unit or an apartment. And so what we have built basically allows our customers to, if you think about an average call of being 3 minutes and time savings per call versus human listening, let's assume 1 million calls a month. That's about 50K hours. And if you put a competitive dollar rate, hourly rate for people that they charge you for doing this, that's a saving of over $1 million there. But more importantly than that saving is actually the gain that we have for marketers, because that platform empowers marketers now to simultaneously prioritize and convert now those inbound leads from phone calls at a rate of 2.5 times of the average in real estate. And so that is because they can figure out which one is a high propensity to lease call, number one, and number two is they can follow up very, very quickly. And that actually increases the conversion rate, and then on the backside of what we do, providing more targeted campaigns, we can actually leverage all of that information to build a superior solution for real estate marketing. So one that simultaneously provides an overview of the customer journey and generates actionable insights for marketers, and all that by leveraging H2O Driverless AI and AWS. And with that, we open this up for Q&A.
All right, great, thank you. Sorry, I had trouble coming off mute there. So we got a couple of good questions in here, and I wanted to make sure we get to those real quick. Let me sort through these. So we have a question, I guess it's tangential, but it might be relevant. One participant, when he heard driverless AI, thought that it was be connected with self-driving cars. So can you tell a little bit of the story around why you chose the phrase driverless AI?
Sure, this is Vinod here. So it's an interesting story, right? So if you look at our core H2O platform products, they all have this water theme name, a naming scheme. So you have H2O, sparkling water, and so on. So when we started working on driverless AI, initially the goal was to see, of course, the self-driving cars are extremely popular, but we are thinking about what does it mean to be a driver for AI? So the data scientist is essentially the driver for AI. They are the ones who are making the decisions on what frameworks to use, what algos to use, and what workflows to put together. And we said, look, if we were to automate data science, then would that be like driverless AI? So the real AI that we are looking at in enterprises is the stuff that we talked about today, like doing call center predictions or call forecasting, stuff like that. Those are all the work that data science are doing. So if we said we automate that, it would be a nice name. Plus, it also was a nice pun on the whole self-driving phenomenon. So the name has stuck on.
Great, thank you. So next one, this is another good one here. Can you comment the reason that one would decide to use H2O over other ML platforms? And they have listed here what appear to be some ML frameworks such as TensorFlow, Scikit-learn. So maybe you could talk to the advantages of using a complete platform such as H2O.ai over, just a bare framework and creating your own processes.
Yeah, absolutely. I mean, obviously, we did some comparison in the beginning. We looked at SparkML and then frameworks as well, specifically in the R tool kit and package world. But I think it became very apparent to us that we need a platform that actually is open on the back-end side, so we can actually at some point tie in TensorFlow when we need TensorFlow, and also combine that with algorithms that are available on that platform. I mean, for example, we use XGBoost, GBM Lite now that's available. And so for us, it was very clear that from an openness point of view, we needed to have a platform that is basically allows us to tie that in. So H2O Driverless actually had exactly that value proposition for us. So we didn't have to go into very different environments and tie them together. So we would have a single framework, and that single framework is very important because then when you go to production, you can then take advantage of the mochos and so on. But the most important part, I think, why we picked Driverless was not just because it's in the framework, but also the performance that came with it. Quite frankly, the virtue vector that we got, first of all, out of H2O3, sparkling water, and then we got to Driverless with the metadata enrichment produced. I mean, really, really great results at the lowest cost or time spent there. And so I think from that point of view, it was not only a highly performant solution, but also a extremely economic solution. And that's why it made the most sense for us to go with H2O Driverless AI.
All right, great. And now, earlier there was a reference made to GPUs for training as well as for inference. So could you touch on some of the benefits of actually leveraging GPUs at the point of inference as well as training?
I can take that. So it's a great question, right? So so there's a lot of interesting new developments coming on with regards to using better chipsets like the ASICs, like GPUs, for example. So on the training side, of course, the big improvement is the fact that GPUs typically have thousands of small cores instead of a typical CPU, which have a few very powerful cores. So you can, if you can parallelize your workload, your task of training the martial model building enough by using all those GPU tensor cores, if you will, then you can essentially parallelize the entire training activity many times over, hundreds of, if it's not thousands of times over. And that can lead to some really interesting results, like, you can go from anywhere from 5 to 30x faster. So driverless AI, for example, on a GPU-enabled box can be anywhere from 5 to 30x faster, depending on basically the type of problem, type of data sets, and use cases. And that could mean massive amounts of savings and time. Now, when it comes to inferences, one of the neat things with driverless is the models are highly optimized to be performant on CPU and GPU. So right now, they work very well on CPUs itself. But generally speaking, when you are building deep learning-based models or other complex models, the GPUs can help with inferencing as well. And there are a lot of GPU instances that are available that are just optimized, including things like the P4 or the TensorRT set of architectures, which are optimized for GPU inferencing. So GPUs are obviously very, very powerful in helping reduce both the training and inference times.
Excellent, thanks. We've got time for about one more here. This is a pretty good one. It's talking about, it's referencing the G5 team here, and they're curious to know what were their specific skill sets and technical expertise leading up to the usage of H2O. And I think what the question is getting at here is what's the ideal type of candidate, or what position should a team be in before they start adopting H2O?
Yeah, I mean, that's a great question. And let's start with number one, myself here. I mean, my background is social sciences. I have a master's in social sciences, and grew up with SPSs, got into R. And I think that's not a requirement to use driverless at all, just to be very clear. So I had a little bit of knowledge, let's put it this way up front. But I think when it comes to really to driverless, what's more important than just the basic knowledge is to understand your business problem. And I would say from the business problem side, then to really understand how to move forward with building a model, that's as simple as it gets with driverless, because at that point, one of the very important features of driverless, which helps you to understand what the model basically really tells you, that is as easy as it gets when you use a driverless environment, because it builds, quite frankly, the right outcome, explains to you, depending on the problem that you solve, for example, in a decision tree about the influence of the variables, the features, so to say. And then I think when you take a model further into production, I will let Jeff talk about that part, but I would just add before I hand over to Jeff that the Mojo Pojo environment here makes it actually very simple. And then from a skill set, I think with a somewhat experienced, Jeff is very experienced, a data engineer, things are very easy. Jeff.
Yeah, so I think what's great about driverless for us is that it does a good job of stemming the tide kind of between Martin's knowledge around data science and my knowledge around data science in production. And then like we mentioned before, we have another engineer who's a great whiz kid at building DevOps friendly infrastructures. And so I think where driverless comes in is filling in the gaps between where we know that there's information in the data, and where we can go out, get our data curated, kind of prove to ourselves that there's something there. And then driverless has just the right number of knobs on it where we can fine tune it with our kind of limited skill set between Martin and I, and come up with models that are truly just wonderfully accurate. We have enough insights that we know how to turn those knobs, but it does enough for us that we don't have to be any smarter than we are.
All right, great. Thanks for that. That's going to wrap up our hour here. There are a couple more questions that got submitted a little bit late that I will try to get answers to. And again, this webinar in its entirety will be available on SlideShare as a download. So watch for an email for attending. And once again, we want to thank you from G5, from H2O, and from AWS for attending today.